Okay, so now we've got our model that we've just created. Now how are we going to use this in any meaningful way? And one, it's helpful for us to just kind of look at it and just see what's maybe going on here. We see that more low birth weights as a percentage for the county doesn't necessarily mean it's caused by, but it's associated with the Food Environment Index. And in this case, the percent low birth weight would go up as the Food Environment Index goes up. That number. Smokers, as smoking goes up, for every 1% increase in smoking, looks like there's a 4% increase in the or a 0.04% increase in low birth weight. Low birth weight here is expressed as a percentage. There's some nuance, or not nuance, but challenges in modeling a percentage variable with linear regression. But I don't think any of the low birth weight values are approaching 100%. So we might have some linearity that could still be used here. As the percentage African American goes up, there's an increase in the low birth weight. As graduation rates increase, assuming, that doesn't go the way that I would expect it to. If my grad rate that I've got wrote down here, graduation rate, so as the graduation rate goes up, it's saying that the percent low birth weight apparently also goes up slightly. As the teen birth rate goes up, so does the percent low birth weight. As the children in poverty goes up, so does the low birth weight. But as the uninsured goes up, the low birth weight rate is inversely associated, so it goes down. So as insurance goes up, low birth weight goes down. As low birth weight goes up. So those are some of the factors that are in this model. There might be other factors that you'd want to put in there, and some of it doesn't necessarily entirely, match up with my, my views here on how I would assume that, the graduation rate would be, as the graduation rate goes down, then low birth weight I would assume would go up, but I don't know. But that's just kind of the rough analysis. We would want to, again, do the VIF and the plots, So if I did the plot, whatever we just called this one previously, model, we gave this thing a name, right? Model new. So then we can look at the different graphs, and none of these probably actually would be placed in a paper. They're useful for you. So that looks like pretty good heteroscedasticity, some clustering there at the base. This is more normal than some of the ones I've seen. So it's nothing too alarming here. No fanning, and so we've got a handful of outliers here and there. So you kind of you've looked at this information. Next, you might then do the VIF on the actual model new, and I have to type this command right, I guess. So we have to use that OLS _ VIF tolerance model new. That's the command here. So we run it. Everything's below 4, so we're doing okay there. The R-squared is 63%. So we could say in our paper, all the variance inflation factors were below 4, and you could even calculate the mean VIF if you wanted to add those up and divide them by, I guess, 7 variables there. So anyways, you've got all that information. Say you're going to go ahead and work with this. I mean, we haven't looked at the residuals yet, so we'll just call it res1 equals the residuals of model new, you know, and then Shapiro test on res1. You know, it's significantly different than normal, but it's a 3,000 data set. You know, it's not ideal, you know, so it's, I mean, you could report that you did a normality test on the residuals, W equals 0.957, p-value is less than 0.05, and, you know, it's, you know, different than normal, and still roll with it, just being honest with what that value is there. But anyways, you're going to want to say you're ready to go ahead and put this paper out there. So you've got this information here. What are you going to do with it? So again, we can go back to our Excel sheet, and you know, you're going to make a table here. Now, with the correlations table, you know, I've wrapped these, so you could put all the correlations in there and have them bolded or whatever. Now that negative sign is up there. We wouldn't want that. We'd want to, you know, have these columns. You'd have to use a smaller font size or something to make this stuff, you know, work. And some journals allow you to make your tables smaller to make them work, the fonts in the tables. But anyways, you're going to now want to make a table that deals with this. Let's go to here. These things. So what goes into this table? If you were to see a scientific paper, what's going to go into it? Well, one, we removed one of the variables. So previously our correlation table had all of them in there, but we dropped the household income variable. So the household income variable here, we're going to delete that and it's going to go away. Now we've got these variables. Some people will take this estimate that's there and they'll call it, you know, coef, or they'll use the Greek symbol b, lowercase b, and they'll use the symbol and make it the Greek letter b, beta. And then you'll see the SE, standard error, and then sometimes it's smaller, sometimes it's larger, symbol, we beta, and that's a lowercase b. It's a little tricky here, lowercase b, and then the symbol font. Standard error of beta. Some people will just write out coef, like this. Well, that's Greek. They'll write out, you know, coefficient or coef dot. Either way is fine. And then they'll sometimes have the just t. They won't say t value. Some people will say t value. And then they'll say p. And for p, for these values that are really small, they'll just do less than 0.0001. And for all of them that are that way, you would use them. Now, one of them down here, graduation rate, when you type the graduation rate in there, and I don't know if it was percentage or persons per thousand or whatever, that is zero, or is less than 0.001. It's actually not. It's actually, you'd write it out, 0.002. You see it? 0.00199. So that's not too far off from where you would actually go ahead and type it out. And you're going to want to keep this probably left aligned here. So you would fill in all those values, and then at the very bottom, I'm going to insert a column here. I'm going to move this up. You would, let's see, maybe it's just easier to write persons who are uninsured, and then change this bottom one to constant. Constant. That term called intercept is your constant. And the only thing you need to provide on it is the estimate. 2.93, and I'm going to round it. 9337 was 2.934. So you'll provide all of these. You may, you know, left align or right align them all, whatever you want to do on that. But you would fill in the rest of these. low birth weight, actually, you're not going to have anything there for that. Food environment index, you'll have something. Low birth weight is not part of this because that's what you're trying to explain. So all of this would go into making a table for a scientific paper. And you'd have to manually go in here and type in the information. And again, it's unnecessary to type in the standard, well, you can put the standard error of the coefficient if you want, but it's usually not necessary. Usually all that they want is that. And then the rest of this stuff, though, you would populate entirely. So that, all this stuff, when it's fully populated, would go into your paper. You know, here's your table. And you would have it filled in with all the numbers that you need there. So, easy enough, right? You would have all the numbers in those various cells. Making the table sometimes in Excel and then pasting in the Word seems to be the most efficient approach for me, and maybe for you. You could build a table in Word if you'd like, but anyways, this is how your statistics end up on paper, and you might find this useful not just for the assignment but for future purposes. So we're going to stop here, and I think we're going to call this quits here for this section, and we'll do one more week of RStudio instead of a quiz to then give you some experience with logistic regression, which is really common in public health statistics because the odds ratios are used a lot by people in public health. So we're going to go ahead and stop there, and if you have questions, you can always get at me. I'm happy to respond as quick as I can. So thank you. Have a good afternoon or day or evening or whatever time you're watching it.